Hi, from the second video of the series Simple and Efficient Dynamic Explorations. We will deal on finding the graph of derivative of a function in this video. Please assume that you know the meaning of derivative of a function. You have just learned the meaning of the derivative of a function, but you don't know how we can evaluate the derivative function of a function. As you know, derivative of a function is a function which maps a point onto a value representing the instant speed of the original function's changing value on that point. This instant speed is measured by the slope of tangent at that point. And now let's begin to observe something. First, we need a function. Let's start by a simple function, x to the 2, x square, and we need a parameter representing the independent value of the function. The name of the parameter a from -5 to 5, and now this parameter is changing from a -5 to 5, but it doesn't control anything yet. This is the x square function, and let's create a point on the curve by writing this ordered pair a fa. As you see, while you sliding the parameter a, the point is changing on the function. You can also view the point on x-axis by writing a0 like this, and if you want, you can connect these 2 points by a line, and you may prefer to make this line dashed. Now we are ready. We have a function and we have a point on x-axis and the point, the image of that point on the curve. Now we have to obtain the slope of tangent at a. To create it, we use this tool. First click the point A, then click the curve. Now we have the tangent line. Let's change its symbol. The slope of this tangent line will represent the instant speed of changing value at the point B or the value A. You can see the slope from the algebra view, but we can also create it as a parameter m, like this. We used this tool, simply clicking on the line. Now we have an independent parameter, independent value, variable, and dependent variable m. This dependent variable m represents the value of instant speed of these functions on the point A, 0.8. Now let's create a point represents the derivative function. Independent variable will be a and dependent variable will be m, and we obtained a new point moving with the a and b points. Open its trace and animate this parameter. We obtain the line. This line is the derivative function of x squared. Let's pause it. Clear the traces and change the function. For example, sine of x. And again, animate the parameter. This trace is a function representing the derivative function of the sine of x. Again, clear the trace and change the function. And animate again the parameter. This curve represents the derivative function of the logarithm of x, natural logarithm of x. And now we can guess, we can anticipate what is the algebraically this function, what the algebraic correspond of this function. But as you know, after these explorations, visual explorations, we can make algebraic calculations by using this limit. So our estimations easily could be controlled.